7.5, factoring linear expressions. Let's go back to distributive property quick. So if I give you something that looks like this, what would you do to distribute that? Multiply, right? And you multiply both of them. So it looked like this, 12m plus 6, right? Okay, so factoring today, what we're going to do is they're going to be giving us this, and we got to take it back to that. Okay, so we're going to be giving this, and we take it back to this. Basically, just the distributive property is all it is. But the first, I have two parts to this today, and we're going to run through this first part kind of quick because you should know how to do this already. The first part is finding a GCF of a monomial, greatest common factor. Okay, you should remember how to do this. This is the tree or the cake method, whichever one do you like the best. I personally like the tree method. I have some vocab after this, just a little bit of vocab, and I'll tell you what you need to write. I have quite a bit on the slide, but there's only a few things you need to write. Ready? All right, so monomial, if you want to, you can write this definition, okay? Because I think that makes more sense to you. So a monomial is a number multiplied by a variable, a number, or just a variable. And then here are some examples of monomials and what they look like. I feel like that the in other words part is a little more down to earth so you guys can understand it. I'm going to get some examples. 40x, x, 25, those are 3 examples of monomials. Then down here are examples of not monomials. Okay, x plus 4, 20x plus 1, those are not monomials. What's that? Yep. Yeah, it's got to involve multiplication, possibly. Because I have that plus 1, because I have 20x plus 1. The thing about these is, if I would break these up individually, they would be monomials. But these are monomials put together, with so 2 monomials put together. So that's the difference between the 2. 1. In other words, too, if you think about what we did the other day, let's say we did, remember we did this, 3x plus 9 plus 6x minus 1. Remember we did that? And we circled the terms. Each of those terms would be considered a monomial. Okay, if sure, we name them. I don't see why not. So everybody understand what a monomial is? Okay. All right. So GCF, we're going to talk about this a little bit today. You don't got to write this if you don't want to, because you should all know what GCF means. Greatest common factor. I feel like you're probably doing this in 4th grade or 5th grade. All right. So what we're going to do first is we're going to just practice finding prime factorization. We're just going to take a step back. We're going to practice doing a prime factorization. And we're going to do 100. Now, how many people like the tree method here? Because I do the tree method. People do the cake method. Anybody remember that? See, there's a reason why I don't like the cake method, and I'll show you why, okay? But I'm going to stick with the tree method the way I do it today, and then I'll show you a little bit of the cake method if you want to see that. So here's the deal. 100. I could do 10 and 10. What else could I do? 25 and 4, 50 and 2. I'm 50 times 2. Okay, what I want to do is I want you to pick what you are most comfortable with, and I want you to make the factor tree starting however you want it. So maybe Hunter picks 2 and 50. Maybe Jacqueline picks 10 and 10. So everybody do the factor tree for 100. You choose which way you want to start. So I'm going to show you. So let's see, you could do 2 and 50. You could do 4 and 25. And remember, when you do the prime factorization, you're breaking it down to all the prime factors in this number. What's a prime factor again? 1 in itself, right? So some of the prime factors would be 2, 3, what else? 5, 7, 11. 2 is 1 because 2 in itself. 13. 2 times 2 is 4. 2 times 1 is 2. Nothing else goes into 2. 17 would be 1. Most likely today you're going to stick with 2s, 3s, 5s, and 7s. That's pretty much what's going to come down to today. I'm going to do 4 and 25 because I figure a lot of you didn't pick that one. 2 and 2, 5 and 5. I like to circle mine as soon as I know that I cannot go any farther on them, because then it reminds me I need to put them in my prime factorization.
Excuse me?
Yeah.
Give me some.
Okay. Thank you. Okay. So then, what I like to do is I like to list out my prime factorization. Okay. Everybody, who did 2 and 50? Come up with the same thing? You should have. Just like 2 5s and 2 2s.
But you gotta circle in the first. Under the bottom. You gotta circle the ones under them. Oh, that's underneath.
Because they're not prime. I'm only circling the prime factors in my tree.
Oh.
So if I do, let's do 10, I'll do 100 and I'll do 2 and 50.
But it's 2 and 50.
Prime. Correct. Right. Then it'd be 2 and 25. Prime. 5 and 5. They're both prime. Same thing. Okay? Correct. Now, a lot of people forget that 9, things can go into 9. 3 and 3. People forget things can go into 4. 2 and 2. So don't forget that when you're making your thing. All right, so everybody remember how to make your tree? Okay. So what we're going to do is we're going to find the GCF of two numbers now. Now, I don't want you to do both of them. This side, you do 60. This side, you do 80. That way we don't have to do both of them. What? I'm going to show you why you can't do that now. All right, so 60. Who's got the prime factorization for 60? We didn't do 60. Riley, what do you got? 2 times what? Okay. Time. Okay, well, 6 can be broken to 2 and 3. Don't forget that. Yep. 6 is another one. What about 80? 5? Okay. Now, this is where people get confused. We're going to find the GCF, the greatest factor that both of these share. So what you're going to do, just listen, is you're going to circle everything they share. They share a group of 2s. They share a group of 5s. They share a group of 2s, right? All right, that's it. That's all they share. So now listen. One group of 2s means 1, 2. They share 1, 2. One group of 2s over here means they share another 1, 2. A group of 5s over here means they share 1, 5. Now, this is where everybody gets confused. You take 2 times 2 times 5, and that's going to give you their GCF. So the GCF would be 20. So many people say, okay, well, to find the GCF, I'm going to take this 2 times this 2 times this 5 times this 5 times this 2 times this 2. No. When they share a group, it's only considered 1, 2. They really only share 1. Then they don't matter. Because they don't share anything else, then they are not considered in the GCF. Okay? Let's do another one. Should we do another one? All right, so you guys do 42, and you guys do 36. You guys do 42. Got it? Okay, so 42 people. Somebody I haven't heard from yet. 42 people. 237? Okay. 36 people? Everybody agree? You guys agree? Okay, what do they share? They share 2 and 3s, and that's it, right? So a group of 2s and a group of 3s, and that equals 6 is their GCF. Okay? Let's do one more, and I'm going to add some letters this time. We did 42, right? Let's do these two. Should be fairly easy. We can probably do these in our heads. So I know 25x, well, I know that's going to be 5, 5, and x, right? When you have a variable, you need to include it in the prime factorization because we don't know what that is. So you have to include that x there. And then 15 would be 3, and 5, and x, and y. So they share 5 and an x. No, this is one group, right? 5x is their GCF. So yeah, so you gotta think about that a little bit, yep. So does everybody understand if you have one group, that's their GCF then, and then add that x on the end. If x was a number, then we can multiply, but we don't know what x is. You know what? The y, is it shared between 25? And no. If they're in your circled group, that's when you can include them, okay? Questions on this part so far? All right, so some of you are like, why are we learning this? Well, here's the second part today, factoring. Okay, this is the part where we're going from the distributive property, or the end of the distributive property back to what it looked like beforehand. Factoring linear expressions, part 2. Part 1 was GCF. This is part 2. Yes, that's first part of the work. Part 2 looks like this. Can I go ahead? Okay. So you don't got to write that definition. But what you're going to be given, you're going to be given this. Okay? And you have to factor it. So what I like to do first is I like to figure out what my answer is going to look like. I know I'm going to have parentheses. I know I'm going to have a number out here. My sign, whatever my sign is, I'm going to pull down along with the variable. Okay? So I'm going to have 3 numbers in here that I got to figure out. This one, and this one. Now some of you might be wondering why I had to find the GCF. Here's the deal. The GCF of these 2 numbers has to go on the outside. So if you don't know what the GCF is, then you do your factor tree. What's the GCF? 3. So 3 goes out here. Then I say to myself, what times 3 would have given me this? What times 3 would have given me this? This is my answer. The end. Okay, let's do another one. You don't need a definition. Product of its factors. 4x plus 28. Figure the GCF out. First, set it up if you need to set it up like this. Yep, exactly like this. GCF goes here. If you don't know the GCF, you can actually do it. So, what do they share, though? They share 2 2's, right? Yeah, so they share 4, so that goes out there. Not 2. Some people think it's 2. So then this should look like this. That's what it should look like. Now let me show you why. What? Yeah, here still has a stuffy nose. Alright, so let me show you this. Let's say to put 2 on the outside. Let's say you didn't find the GCF and this is what your answer was. The reason why you cannot have this is because you're trying to write this as a product of its prime factors. Are either of these really prime? Well, this one is, but can you still take something out of there? Do they still share something? They still share 2. So you have to make sure you get this as low as possible. Not necessarily. This one, no, this one won't probably be prime. Sometimes it might. Sometimes the inside you want it to be as low as possible. If these 2 still share 2, I still have to be able to take. I got to take something out of there yet. I want it as small as possible. Okay, so they do not share anything. Why don't we try this one? Let's talk about this one quick. You can do this one. Does it matter matter what order they're in? No, not at all. What do they share? 3. So it'll be 1. Should look like that. Hmm? You should be able to. Yeah, that's fine. Nope, the x has got to stay with whatever. I mean, you can multiply. I mean, it should be 3 and then 33x. You can't put the x with this because that would change this then. One I want to show you is this though. Look at these two. 12 and 7. You can have variables with both of them if you want. Doesn't really matter. First, look at the numbers. 12 and 7. They don't share anything, do they? Okay, so that's okay. That just means they can't be factored. You just write not possible. Not possible. If you try to factor, this is what it's going to look like. But guess what? It's not the same thing. So it really can't be. So you just write not possible. It is the same thing. It is the same thing. Yep, it is. That's why it cannot be factored. One's the only thing they share. It looks the same way. So, one thing I do want to show you is this, though. In your homework today, it's going to give you a picture. Okay, don't freak out when you see the picture, you guys. This is just like what we've been talking about. All you need to do is, if this is your area of your garden, if you're going to add the areas together, guess what it looks like? And then you factor. That's it. So it would be 3, 5x plus 6, right? Sometimes they might do this, and they might throw a third section in, and they might make that 12. If that's the case, nope. If that's the case, then you do this. 12 plus 15x plus 18. Put these two things together, and then you factor. You can have, now we're only working with 2. In Algebra 1, you work with 3. We're only working with 2. We're staying simple. So, do you guys have questions for me at all? Your first about 6 are finding GCF. The last ones are you finding factoring some stuff like this. You don't really have to show work for this, you guys, unless you don't know what the GCF is. Then you probably got to figure out what that is. Otherwise, you really don't need to show too much work.